Okay, let's. I'm recording, by the way, just for those people that haven't turned up. So quadratic formula, you've got A, B, and C. What did you have as A? 2. B is. It's just 4, positive 4. And then C will be -1 because we have to rearrange this to give it 2x squared plus 4x minus 1 is equal to 0. So this is the one we're having to use. Okay, so that's A, that's B, that's C. Is that all right so far? You agree? Okay, so we've got it's minus B plus or minus square root. I always write it out all over 2a. So I'm going to put those in. So I've got minus whatever b is, plus and minus the square root of 4 squared minus 4 multiplied by 2 multiplied by -1 all over 2 times 2. Okay. So we end up with -4 plus and minus the square root of, well, that's 16, subtract 4 times 2 is 8, times -1 is -8, so I've got that. So that's -4 plus or minus the square root of, well, that's 16 plus 8, which makes 24 over 4. So our two solutions will be -4 plus root 24 over 4 and -4 minus root. So when you say the answers, was it in exact form or in decimals? Simplified to exact form. So what do you get if you simplify these?
-2 plus 6.
So can we simplify 24 at all? Because root 24 is the same thing as root 4 times 6, okay, which is then root 4 multiplied by root 6, which is 2 root 6, okay? So then I'm going to have -4 plus 2 root 6 over 4. So what we then get is there's a 2 in all of these, so I can cancel a factor of 2 out, yeah? So that gives me -2 plus root 6 over 2. Can't do anything else, right? And then this one again would be -4 minus 2 root 6 over 4. So again, cancel the 2's, gives me with -2 minus root 6 over 2. So, is there any problem with the answer in the book, or? Yes, no? We understand? Do you spot any mistakes? That's it. So do you see where you might have gone wrong, or did you go wrong in this area, or did you go wrong when you were simplifying?
Yeah, I think it was also simplified.
Yeah. Okay. Well, other than that, then I think that's all right. If you can spot where your mistake is now, then that's good. Okay, any other questions you might want to have a look at, go through before we have a quick look at our discriminant or determinant thing? No? Nothing? Come on, guys, bit of interaction. We're good to move on? Yeah? Okay. I've got all this videoed, by the way. I'm going to put it out there as the most boring lesson going. No one speak. This is, I'm going to send it to BBC News and go, this is what teaching distance learning style is like. All right, so what we've got here is we're going to use the discriminant to determine the number of solutions a quadratic function has, and then we're going to look at whether we can solve the problems that they're talking about. Okay, so I'm looking at practice 6, the next one on. So that's on page 433. Okay. So when it says, by considering the discriminant of each one, first off, determine how many solutions there will be, distinct solutions. All right, and then it says, can you determine whether it's factorizable or not using the discriminant? So do you remember what the discriminant was, or I was calling it the determinant?
What part of the
Just what is it? Yeah, tell me what to write down.
Does it tell you like how many solutions there are?
Yeah, well, yeah. Well, what is it? What are the letters? What's the part of the equation? That's what I meant.
Root b squared minus 4.
So it's actually just the b squared minus 4ac, not the root. We don't need to put the root in because this is the bit that then, if I root it, tells me what the number of solutions are. So this bit here, this on its own, is the discriminant. And what did we say? That it has 3 options. It could be a positive number, it could be 0, or it could be a negative number. Okay. What did we say? If it's positive, what does that mean about the number of solutions? Yeah, so we've got 2 solutions here. If it's 0, 1 solution. And if it's negative, 0 solutions, or 0 real solutions. Okay, and that's because if you square root a positive number, you've got the plus and minus, 2 different things. If I square root a 0, I get 0, so that's why I'm only going to have 1 option. And I can't square root a negative number, so that's the problem. So when we say, let's work out how many solutions this has got, we literally just put in our b squared minus 4ac and say, right, so again, a is 2, b is negative 3, c is 2. So we kind of go through the process, but we only do it for the discriminant. So that would be negative 3 squared minus 4 times 2 times 2 gives me 9, subtract 16, which equals negative 7. So what's the conclusion?
No solutions.
Yeah, 0 solutions. Okay, because we can't do that. All right, easy enough. So the question for one of them then, let's have a look at, so that was just A. Let's have a look at E. So we've got 4x squared minus 28 plus 40 is equal to 0. So A is 4, B is negative 28, C is 40. Let's do it again. So negative 28 squared minus 4, lots of 4, lots of 40. Can you tell me what that calculates to, please?
For me, the computer is kind of like lagging.
Okay.
Can't see. Yeah, it doesn't show up. Oh, there it is.
Fair enough. I think that happened to us last time, actually. It might be to do with the recording.
So I got 784 minus 640.
Oh, sorry. 784 minus
640.
Okay. And what's the answer? Okay. All right. So this is an interesting. How many solutions does it have then? So we have 2 solutions. Now, the next part, guys, is so part 1 for all those questions is how many solutions. So we can get that. That's simple enough. Okay, but part 2 is can it be factorized? Okay, so I'm looking at this now. So I could try and solve it using vertex form or the quadratic, but the first option, probably the easiest option, is, well, actually, could it just be factorized? All right, now what does that answer potentially tell us about whether it can be factorized or not? Any ideas? Yeah. What does that mean? What do you think? Why though? But why?
Because you could have, well, the roots could be the same number then.
But they won't be though, will they? Because if we were to look at the whole formula, the minus b plus or minus the determinant bit divided by 2a, we would now have 28 plus the square root of 144 divided by 8, or we would have 28 minus the square root of 144 over 8. So as you said, that's a square number, so we then have 28 plus 12 over 8, and we have 28 minus 12 over 8. These two, right, they're not the same solution, are they? No. But what is important about them? The fact that I've got a nice square number there rather than a non-square number, what does it mean? So 28 minus 12 would be 16 over 8. 28, sorry, wrong way around. That should be 16 over 8, and this should be 40 over 8. What do you also notice about that stage? You get a whole number. 40 divided by 8 is 16 divided by 8 is 2. Okay. What normally happens when we use the quadratic formula and you can't factorize? What normally does the question say to give your answer to?
Exact form, or sorry, decimal places?
Yeah, so either an exact form, which gives you a clue, or it says give it to 2 decimal places if they want it in as a decimal. They ask you to round it. So if we use the determinant and we find actually we've got a square number here, a square number is the only number that you can square root and not end up with. What's it called? If I square root any other number other than a square number, what type of number do I get? Any ideas? So if we square root a non-square number, what is the result? What do I get? So if I square root a square number, I get an integer value. But if I square root a non-square, what do I get? But I get something else. I get an irrational number. And what's an irrational number, guys? Yeah, it's a non-recurring decimal, okay? And we've looked into that with our surds, you know. If we do the square root of 16, the answer is 4. But if I do the square root of a prime number, I can't do it. It stays as it is. If I do the square root of 50, which isn't a prime number, but that changes to 5 root 2, and it has a prime factor in there, doesn't it? So all our numbers have prime factors, and the only ones that we don't worry about that is with a square number. So every other number other than a square number, we end up with the root of a prime factor. So it's always going to be an irrational number. So in my solutions, if I end up with a nice square number, there's a good chance it's going to be able to factorize instead. Okay, does that make sense? Yeah? Okay. If everyone's happy, we've got no questions on there then. Let's have a look at the next bit, which is the problem solving. So let's see how we can use the determinant. So question 2 for the problem solving, the question is 3x squared plus kx, so we're not told what k is, plus 12 is equal to 0, and we are told that there is one solution. There is one solution to this equation. All right. Now, as soon as we're given a question like that and we're asked to find k, if we're saying find k, there's one solution, that brings something to mind. Always, it should do for you guys now. What are we going to have to use? The discriminant. We're going to have to use b squared minus 4ac, because that's the link that we've got between the number of solutions and a quadratic. What do we know about the discriminant if it's only one solution? It equals 0. Okay, so we're using this. So over here, we've got a is 3, b is k, and c is 12. So we put that in now. So we get k squared minus 4 times 3 times 12 has to equal 0. Is it still lagging, guys? Should I give it a chance to catch up? Okay, so I've got k squared subtract 144 in this case must equal 0. So how do I find out what k must be?
44 and then square root both sides.
Yeah. So k squared is 144. Therefore, k is the square root of 144. So what is the equation then? If I were to complete this equation, I would have 3x squared plus what? Not 12k, 12x. Yeah. Plus 12 is equal to 0. Any other options? Or is that it?
That's good, because it said it has one solution.
Right? You sure? No other options? Because what's k? What's the value for k? I didn't write it down for a reason. It's not a trick question, guys. K is 12. That's why you put plus 12, yeah? Couldn't be anything else? No? Anyone else? Thanks, Izzy. Why could it be negative 12? The square root of 100. So what do we think, guys? Could it be 3x squared subtract 12x plus 12? Would that also work? Yeah? So your plans then. When's the assessment this week? Wednesday. Okay, you are going to be assessed. Basically, we're going to do another Ed puzzle thing like we did before. You're going to be assessed on your ability to factorize, write in vertex form, find solutions using factorized vertex form, quadratic form, use this discriminant as well to solve a problem, all of that sort of stuff. Just maybe a half an hour one to fit into that 40-minute session, but be a nice criterion A assessment for you. Okay, put it down as
that in unit 11.2.
I think so. I think pretty much just what we've been doing most recently. 11.2, just solutions section. So you have to already be able to factorize before you can solve. So yeah, it's pretty much just all the solutions stuff. Okay, that we've been working on the last couple of weeks. So that's what I'm going to be testing you on Wednesday, right? So make sure you're able to do all of that and do this discriminant stuff that we've just covered today, right? So that'll be your lesson tomorrow, will be to prepare and review for that. As for your end of year assessment, we'll end in 10 minutes. I do believe now that there's not going to be any kind of formal test as such, okay, for your end of year assessment, which I think is quite good. So we'll just go ahead once we've done this final assessment and then we've done the problem solving stuff. That'll lead us nicely into you doing another version of that modeling task, all right, that we did for the basketball, but I'm going to set one up to do with like a motorbike jumping over a river or something like that. I'm going to another criterion D. So that will be your summative assessment for this unit. Okay, so I think the one on Wednesday is down as a formative. So it just gives you ideas of like whether you can factorize the stuff. And then you'll be using that for your modeling task again. Does that sound all right, guys?
Modeling task would be like an essay where we get like the weekend, or will it be an hour thing?
Oh no, it'll probably be you'll have the week's worth of lessons to do it. Yeah, no, it's not going to be a one-off one that we wouldn't get it done in time. You're going to have to find a model and refine the model and decide if the model is relevant or how it fits, and if it doesn't, you've got to change it and blah blah blah. So we went through all that about how to get the difference between discuss, explain and justify for criterion D, and that's what I'll be looking for that one. So I'll give you definitely probably a full week, if not a little bit more, to get that done, all right, during the maths lessons, so you can hand in a really good piece of work. All right, any other questions on what's going on Wednesday? Make sure you can access your Ed puzzle again, because it's going to be that kind of thing. I'm just going to put the questions and you're going to respond to them on Ed puzzle. Any questions on this discriminant stuff? Pretty simple, right? Discriminant stuff. I feel like I'm talking to myself. Yeah, I probably am. So practice 6 and whatever any review you feel you need to do, that'll be your task for tomorrow. Bright and early. If you are late to Wednesday's lesson, I will have locked it just like I did today, and then you won't be able to do the assessment. Okay, so let people know. If there's no more questions, then